Hi guys, today we're going to cover section 3.4, operations on functions. So if you look at the notes right now, it's pretty self-explanatory. So you have your typical plus, minus, multiply, divide on the functions. And what we're going to focus more on this section is actually the composition of functions. Composition of functions. And the domain. The domain is going to be a little bit confusing for a lot of people, so try to bear with me, try to follow along as much as you can. And let's go ahead and get started. Okay, so if you look at number 2, it says let f of x be x squared plus 5x plus 1, and g of x is x squared minus 4. Perform an operation and find the domain of the resulting function. So in this case, if you think about it, all we're doing right now here for part A, we're just doing f plus g. Okay. So essentially, all we're doing is we're just saying x squared plus 5x plus 1 plus x squared minus 4. And we can combine like terms. Okay, so this will be x squared plus x squared is 2x squared. 5x is by itself. And 1 plus a negative 4 is a minus 3. Okay. Now, as far as domain, there's a domain for this. Notice, this is a quadratic, which is a polynomial. Any polynomial, the domain is always all real numbers. So from negative infinity to positive infinity. Okay. Anytime when you have a polynomial, the domain is always all real numbers because you can plug in any number you want without a restriction. Okay. All right. Number 2, part B, f minus g. So just like previous question, now this time we're subtracting. So, in this case, right, x squared minus x squared cancel. 5x minus nothing, so that's still a 5x. 1 minus a negative 4 is a positive 5. Okay, so in this case, again, this is a linear, and linear is also all real numbers for domain. All right, remember, linear is part of the polynomial. So, okay, part C. This time we have multiplication. So this is just x squared plus 5x plus 1 times x squared minus 4. Okay. All right. I'm gonna just use some different colors. So x squared times x squared is x to the 4th. X squared times negative 4 is minus 4x squared. 5x times x squared is plus 5x cubed. Uh, 5x times negative 4 is a minus 20x. And I'm going to run out of colors pretty soon. 1 times x squared is 1x squared. And I guess I'm not going to run out of color. 1 times negative 4 is a minus 4. Okay, so now combine like terms. Is there anything to combine actually? Oh, I guess we do. X to the 4th. I got that. And plus 5x cubed. And x squared, so you got a minus 3x squared. And you have a minus 20x. and minus 4. Okay. And anything else do we miss? Do we miss anything else? 4 squared cubed. I think this is it. Okay. All right. Last part, but not the least. You have f over g. So this is x squared plus 5x plus 1 over x squared minus 4. Now, if we can reduce, we will. Okay. Then we will. But in this case, I don't think it is reducible. The numerator is not factorable, so I can't really do anything about it. So this right here is our answer. And the domain, right? X squared minus 4 cannot equal to 0. So x squared cannot equal to 4. And square root both sides. X cannot equal to plus minus 2. So that means we have negative 2 and 2. And everything else. So final answer, negative infinity to negative 2, parentheses, union, negative 2 to 2, union, 2 to positive infinity. Okay, negative 2 and 2 are our restrictions. So everything else is fair game. And that's why we have 3 different intervals. Okay. All right. Now for number 3, right? Number 3 is pretty similar to number 2, except this time instead of x, we have numbers inside. Okay, so all we gotta do is just plug it in. So f plus g, right? If you remember from previous, f plus g just means f of x plus g of x. So that means f plus g of 3 just means f of 3 plus g of 3. Okay, so in this case, essentially what we're saying here is this is x plus 1 plus x minus 5, and this just means 3 plus 1 plus 3 minus 5. Where we see x, we replace with a 3. Okay, so pretty straightforward. This is basically 2x minus 4, and this is just 4 plus a negative 2, which is 2. Okay, so the answer in this case is 2. Okay. Alright, so the rest actually is pretty straightforward, right? So f minus g of 2 just means f of 2 minus g of 2. Okay, so again, I probably should write this down beforehand. So f of x is x plus 1, and g of x is x minus 5. So this is just 2 plus 1 minus 2 minus 5. So 3 minus negative 3, which is 6. Okay. Alright, so for f times g of negative 2, right? So again, this is f of negative 2 times g of negative 2. So this means negative 2 plus 1 times negative 2 minus 5. So this is negative 1 times negative 7, which is 7. Okay, please do not FOIL. Okay? If you know the value for x, you don't have to FOIL. Just plug it in and call it good. Alright, the last one, f over g. So this is x plus 1 over x minus 5, but we are doing f of f. We're doing f over g of 5. So this is just going to be 5 plus 1 over 5 minus 5. So we got 6 over 0, which means no bueno. This is undefined. So f over g of 5 is undefined. 0 cannot be in the denominator. Okay, it does happen. When, we don't know, but it does happen sometimes. Okay? Alright. So I'm going to just go ahead and get a new page. Now, for number 4, we're going to be doing something called the composition. Okay, so composition, the symbol looks like this. Okay, the definition of a composition is this: f circle g or composed of g is f of g of x. Okay, so notice g of x is inside f of x. Alright. So let's go ahead really quick. Let's go ahead and find the composition of part A. We will talk about the rest in a little bit, but I want to just do one example really quick so to kind of get your feet wet. Okay, so if f of x is 2x over x plus 3 and g of x is negative x plus 1, so f circle g of x is going to be definition f of g of x. Okay, so once you get to this part, right, using the definition, we're just going to go ahead and plug in g of x. Now, what is g of x? G of x is negative x plus 1. So where you see g of x, I'm going to put in negative x plus 1. Okay? So, now notice, once I replace the g of x with negative x plus 1, the only function that's left is f. Okay, so then I'm just going to go ahead, look at the function for f, and plug in wherever I see an x. I am going to plug in negative x plus 1. Okay, so here we go. So 2x becomes 2 times negative x plus 1. X plus 3 on the bottom becomes negative x plus 1 plus 3. Okay? So, simplify. You get negative 2x plus 2 over negative x plus 1 plus 3, which is negative 2x plus 2 over negative x plus 4. This right here is f circle g of x. Okay. Now, let's look at the domain, right? The domain is going to be a little tricky because there are actually 2 things you got to look at. G of x and f of g of x. Okay, and then we're going to find where they overlap. Right, the reason we have to look at g of x is, now remember, g of x is the first function that we use, right, to substitute. So if g of x doesn't work, this whole function doesn't work. So this is the reason we have to make sure that g of x works. Okay. Now, the reason we have to check f of g of x, right, so basically, our final function, that's pretty obvious because that's the function we ended up with. So we gotta make sure it works. Okay. So again, we are going to check g of x. Whoa, what happened? What just happened? So we gotta check g of x, and we also gotta check f of g of x. Okay. So now g of x. What do you know about g of x? G of x is a linear function. So the domain is all real numbers. Okay. F of g of x. So our final answer, right? The domain is everything except x cannot equal to 4. Right? Because if you plug in 4, we get a 0 in the bottom. Oops. Sorry, excuse me. There you go. X cannot equal to 4. So that means in this case, the domain is what? The domain for the final answer, where they overlap, is going to be, if this is what it looks like on the number line. So from negative infinity to 4, union 4 to positive infinity. This right here is the domain. Okay. We can do a couple more. All right, let's go ahead and let's do one that's g of f. So here we go. So g of f. Now, g of f is just backwards of f of g. Sorry, not f of g. F circle g. I need to correct the way I say this. Okay, so this is g of f of x. Alright, so again, if we just first thing first, plug in f of x. So you get g of 2x over x plus 3. So once we plug in the function of 2x, right, the 2x over x plus 3 into g, and then we can go ahead and simplify. Now, remember, g of x is negative x plus 1. So this means wherever goes in here will go in here. So g of 2x over x plus 3 becomes negative 2x over x plus 3 plus 1. Okay. So you get negative 2x over x plus 1, x plus 3 plus 1. Okay. Now, I will be okay with this. If you left the answer like this, I'm totally okay with that. Okay, this is totally fine. Alright, domain. Again, right, domain, we gotta figure out the inside and overall. Right, so in this case, f of x is 2x over x plus 3. The domain for that is x cannot equal negative 3. G circle f of x is negative 2x over x plus 3 plus 1. So same thing, domain is the same as above. X cannot equal negative 3. So which means, where do these overlap? Well, if they both cannot equal negative 3, that just means your final domain is just going to be x cannot equal negative 3, or negative infinity to negative 3, union, parentheses on both, negative 3 to positive infinity. Okay. Yeah. So typically the students that do not have a lot of issue with composing a function, But what they do have issue with is the domain. Okay. All right. So let's try a couple more. Let's just finish out. So f circle f. Right. So this means f of x. So that means we got to plug in our f. Now I forgot what f was. F was 2x over x plus 3. So this means f of 2x over x plus 3. Alright, now notice, right, the function f itself is a fraction. So basically in this case, we are going to have a fraction inside a fraction. So this is going to be 2 times 2x over x plus 3 over 2x, it's going to be 2x over x plus 3 plus 3. See, wherever we see x, we replace with the fraction itself. Okay? So now, this is the reason why I ask you to do those review sections before class starts, because in this case, we're going to multiply the top and bottom by x plus 3. Okay, I'm going to erase some of this just because I need space. So if I multiply the top and bottom by x plus 3, notice, cancel. So you end up getting 4x on top. In the denominator, you have to distribute. So you get 2x plus 3 times x plus 3. Which is 4x over 2x plus 3x plus 9, which is 4x over 5x plus 9. Okay. So not a lot of stuff going on. The only thing we got to worry about is the denominator. So 5x plus 9 cannot equal to 0. That means x cannot equal to negative 9 over 5. Okay. So domain, right? So if you look at it originally, the domain for f of x cannot equal negative 3. Now the domain for the final function is x cannot equal to negative 9 over 5. So that tells me if I drew a number line, I have negative 3 right here. That's open. I have negative 9 over 5. That's like a negative 1.8, which is right here. And my domain will be everything else except those 2 points. So from negative infinity to negative 3, union negative 3 to negative 9 over 5. I run out of space, sorry. Union negative 9 over 5 to positive infinity. Okay. Whew. Yes, you will get plenty of exercises on this problem. Alright, and I will do g of g. Definition, g of g is g of x. So this means I'm going to plug in g into g. So g is negative x plus 1. So here you go. So now, once I evaluate, once I simplify the function, right, after I plug in negative x plus 1 into g, so that means wherever I see x, I am going to replace it with a negative x plus 1. So this is negative of negative x plus 1 plus 1. Okay. Simplify, you get x minus 1 plus 1, which is x. Okay. Alright, so g of x is negative x plus 1, and g circle g of x is x. And when you look at the domain for this is negative infinity to positive infinity, because it's a linear function. X, again, you can plug in any number you want for x, so negative infinity to positive infinity, right, all real numbers. So final answer is negative infinity to positive infinity, because they're all real numbers. Okay. Yeah. This will take you a little bit of time, so don't rush. We'll work through this, right? Okay, let's look at let's go ahead and look at part B. You have square root of x plus 3 for f. And your g of x, you have 2x minus 5. So f circle g is going to be f of g of x. I always start like this, okay? If you get sick and tired of it, I'm sorry. This is just how it works, and it's a lot foolproof this way, so I don't screw up. So g of x, I replaced g of x with 2x minus 5. And then now worry about the f function. The f is the square root of x plus 3, so this becomes square root of 2x minus 5 plus 3, which is square root of 2x minus 2. Okay. Domain. G of x is a linear function, so domain is all real numbers. The final function, you have a square root of 2x minus 2. That means 2x minus 2 has to be greater than or equal to 0, right? We can't have imaginaries. So 2x is greater than or equal to 2, x is greater than or equal to 1. Which means bracket 1 to positive infinity. So from 1 to positive infinity, we have this. And then we have another line that's all real numbers. So our domain in this case is just going to be where they overlap. So our final domain is going to be from 1 to positive infinity. Okay. Yeah, it's just got to be careful. You just have to be really careful. Okay. I will do the g of f, and then I will let you guys do f of f and g of g. Okay, f of f, g of g. That one I want you to try, and if you got any questions, please do ask. Okay. So here you go. Here is g of f, g circle f. So this is going to be g of f of x. G of the f of x is the square root of x plus 3. Remember, g originally is 2x minus 5. So wherever you see x, you're going to put in that square root of x plus 3. So 2x minus 5 becomes 2 square root of x plus 3 minus 5. Okay. Can't do anything else with that equation because that's a square root. So that's it for that. Now the domain for f of x is x is greater than or equal to negative 3. Right? Because x plus 3 has to be greater than or equal to 0, so x is greater than or equal to negative 3. Final function, g circle f of x, right? G circle f of x shares the same radical, so we can assume that they have the same domain. So final answer, since these are the same, so our final domain is just going to be that. Okay. Yeah, now I'll let you guys do F circle F and G circle G. Alright, part C. Part C, our f of x is 3x over x minus 1. G of x is 2 over x. So if we were to do f circle G, it's going to be f of g of x. Which means plugging 2 over x into g of x, I have f of 2 over x. So now I have to take the x in f and replace all the x's with 2 over x. So 3x over x minus 1 becomes 3 times 2 over x over 2 over x minus 1. Make your life a little easier. Multiply everything by x, because that is our common denominator. You should get 6 on the top and 2 minus x on the bottom. This means domain is x cannot equal to 2. Okay. Alright, so let's look at our domain. Right, domain g of x. G of x is 2 over x, which means x cannot equal to 0. F circle g of x is 6 over 2 minus x. That means x cannot equal to 2. So our domain, 0 and 2, those are both open. And our domain will be everything, everywhere else. So our domain will be negative infinity to 0, union 0 to 2, union 2 to positive infinity. Okay. Alright. I might as well keep going. G circle F. So that means g of f of x. Wherever I see f of x, I replace with the fraction. So this is g of 3x over x minus 1. Okay. Alright, now take this 3x over x minus 1, plug into the function for g. Now remember, g is 2 over x, so this is 2 over 3x over x minus 1. Okay. Now remember, dividing by a fraction means you need to take the reciprocal, so this is the same as 2 over 1 times x minus 1 over 3x. So your final answer is going to be 2x minus 2 over 3x. Okay. So check this out. The domain for the final function is x cannot equal to 0. The domain for f of x. F of x is 3x over x minus 1, which means x cannot equal to 1. The G circle F we just found, this is saying x cannot equal to 0. So final answer. Here's 0, here's 1. Everywhere else except those values. So from negative infinity to 0, union 0 to 1, union 1 to positive infinity. Okay. Alright. Again, I will let you try F circle F and G circle G. And try it out and see if you can get it. Okay.